We present PaperTrail, an augmented reality authoring system which enables instructors to adapt their existing paper-based teaching materials to immersive formats. The system enables enhancing paper with various kinds of digital content, animations to demonstrate dynamic concepts, and clipping masks to guide students' learning. To inform the design of PaperTrail, we implemented 5 target use cases. First, we explored using AR to create layered physical and digital diagrams for a wireframing activity in an interaction design course. The student adds to the physical layer by drawing arrows to indicate screen transitions for their app design. They can add to the digital layer by capturing hand-drawn sketches as AR objects. This digital layer allows the student to experiment with different layouts and reuse physical content without the need to redraw the sketches. Here, we show how immersive paper could be used collaboratively in a tutoring session on orbital and escape velocity. The instructor inserts digital captures of drawings on paper and animates them in order to show the differences in speed and motion of a satellite. The student shares a view of the immersive paper and can manipulate the digital content to ask questions and demonstrate their understanding. This immersive chemistry lab notebook allows the student to integrate a variety of digital media with paper, using hands-free interactions. Here they insert audio clips to record observations while performing a titration experiment. They can also annotate digital images depicting the experiment setup and refer to a video for the procedure. This biology poster demonstrates the use of clipping masks, which can be used to selectively hide and show content. Here, an instructor enhances an existing poster in their classroom, illustrating the cross-section of a cell. To explain the function of specific organelles, they augment the poster with hand-drawn sketches, digital photos, and even animations. When students inspect the poster using an iPad, they can expand the clipping masks to zoom into a particular organelle and view details about its function. Our final example is an immersive MOOC notebook that allows for more natural note-taking when learning with online lecture content. Students can take notes by hand on one side of the book and load course videos on the other side of the book. They can also add video bookmarks to save the timestamps of critical moments in the lecture, and return to these timestamps in the video by clicking on the digital bookmark. Now, using the iPad Pro and HoloLens 2, we walk through the example of an instructional handout for torque and angular momentum, which we also utilized for system evaluations with PhD students and XR design experts. To demonstrate the direction of torque in a printed diagram, a physics instructor captures a hand-drawn vector as an AR object and aligns it popping out of the paper. Next, she uses animations to demonstrate 2 scenarios where a force is applied to a uniform rod. These dynamic illustrations could allow students to immediately understand the behavior of the rod, as opposed to prose descriptions or static diagrams. To provide students with hints on a derivation problem, the instructor integrates an audio recording as well as digital hints using clipping masks. When students want to receive a hint, they can expand the clipping mask. Finally, the instructor captures a video of a gyroscope demonstration to provide students with background information within the handout itself. We used PaperTrail in an elicitation study with 7 high school instructors to explore how they could envision utilizing immersive paper to support their own teaching. One instructor prototyped a physics problem set using AR to simulate how a roller coaster cart is affected by different forces, like spring force and friction. Another instructor adapted a macromolecule building activity to an immersive format, where students can directly manipulate and break off molecules to form new carbohydrates. Please refer to our paper for more details on our design process and insights from our studies.